thank you very much, David, and thank you for inviting me to come and speak here. I've spoken at several BISA webinars now, and it's actually a real pleasure to come and do it for real in person. I'm going to talk about ventilation and why it matters for health. And I think we kind of know why it matters for health. We can't have escaped the fact we are still living through a pandemic, even though the real worst of it is behind us. These figures are a little bit out of date now, but there are, well, over 500 million confirmed cases. That's a massive underestimate in the world. And WHO's estimates in the summer were of over 6 billion deaths. They know at the time that that was a massive underestimate, and said even at the time they thought it was 15 million. And all of those people, or the vast majority of those people, caught that disease in a building, because we know that transmission indoors is far higher than transmission. But if we look at WHO statistics for causes of death, these are annual causes of death. The first thing you note, if you look at the numbers, you can see that COVID just dwarfs what happens with every other disease. But the vast majority on that list are related to air quality, either outdoor air quality or indoor air quality. Some very explicitly around respiratory infections, COPD, lung cancers. Others, perhaps less obvious, things like heart disease and stroke, and Alzheimer's, which we know from evidence are related to air quality. So the reason we care about this is because of health. That's the number one. Before the pandemic, there was a lot of growing interest in indoor air quality. It was great to see that happening across the UK government, across a number of bodies who were really raising those issues about health across the life course, about children and health. And in fact, January 2020, NICE put out indoor air quality guidelines for homes. Great to see. I think that got probably pushed under the radar a bit because world events took over. And if we want to manage indoor air quality, we know the basics on how to do it. Any air quality problem, you start with the source. Can we reduce those sources? Can we reduce emissions from building materials? Can we limit emissions from processes in buildings? But that's not always practical, especially when your source might be people. So then we need to manage those pathways and exposures to people. And that's where the ventilation bit comes in. But don't we know? Don't we already know this? Yes, we know ventilation matters. But we have these trade-offs. And I think at the moment, that trade-off is far more acute than we've ever seen. And the sad fact is that it's much easier to see the pounds in your bank and the energy cost than it is to see what happens to health. And when buildings affect people's health, often not that visible. So unlike things like fire safety or structural collapse of buildings, it's hard to say ventilation caused death. But we know it happened. So even if you think about the pandemic in the UK, there are about 200,000 deaths now, even if only 5% of those were to do with the indoor air. I think that's probably an underestimate. That's 10,000 people. And that's just one disease. That's not thinking about all the hundreds of thousands of people who have asthma, all the hundreds of thousands of people who work in buildings and are exposed, or in their homes, who are exposed to pollutants, poor air quality on a daily basis. But we've got this real challenge that, particularly this year we have a poor building stock. We have, particularly in domestic environments or lower quality buildings, we are going to see people turn the heating off. We're seeing people shut their windows, reduce the ventilation, and prioritize, unfortunately, energy over that health. So we need evidence. We need the evidence to enable us to create those healthy indoor environments. We look over the years, we can see we had evidence once. Go back 130 years, ventilation rates were there around infectious disease. They were there for health. We recognised it. People like Florence Nightingale spotted this. You create good environments, you reduce people being sick. But then over the years, the ventilation rates we have are much more around odour, and comfort and energy. And you see every time there's an energy crisis, we reduce things. down to the minimums again. Where do we need to be? Very good question. But we aren't even where we should be in large numbers of buildings. We should be at 8 to 10 litres per second across the vast majority of our building stock. We're not. So what do we need? Evidence. There's loads of stuff that people ask for. I mean, the big one, the holy grail, is this ventilation or this air cleaning reduced some form of health effect. But that's actually very hard to get. But we need all of these other things in the way. We need to know what pollutants there are. When are we exposed to them? Where are we exposed to them? What concentrations we're exposed to? How that varies across different settings? Where do we put ventilation and air cleaning compared to other things? All of these things. Does the technology we've got, lots of magic technology that people are selling out there, does it work? Does it do what it's supposed to do? Behaviours. It's all very well having all the great technology, having some standards, but if people don't do what they need to do to make these things work, it will not work. And of course, the cost benefit. So I'm going to touch on a few of these things as we go through the rest of the presentation. I'm going to go back to January 2020. It seems a really long time ago now, doesn't it? It's not, but it does seem like it. At that time, me and many others in the world of academia in this space were busy writing research grants to apply for research networks, because actually the research funds had recognised there was a gap here around air quality, recognised that we needed some to stimulate research. So we set up these research networks. I was busy writing one called Breathing City, Future Urban Ventilation Work. I submitted that in January 2020 together with Henry, who's sat at the back here. Then kind of forgot about it for a while, and then, these things were funded. Great, but these were written before we had a pandemic. We wrote this. Said we were going to look at the interfaces between indoor and outdoor air. We were going to look at how ventilation design for health works. We're going to look at how we do regulation into practice. And we are doing all of this. But then the pandemic came. And I think for everything negative about the pandemic, the one thing it has done is accelerate an awareness of indoor environments and ventilation and understanding. And it's nowhere near where it should be, but it's a heck of a lot further ahead than it was 2.5 years ago. It made us realise that people can be the source. They're everywhere in buildings, that there is no sort of single risky place. Risks happen in all sorts of places. It showed us, again, this thing about behaviours. It showed us some things about sensors. Actually, we've seen a massive proliferation of low-cost sensors and their understanding and use in buildings since then. And I think it added to our knowledge about strategic weaknesses. We know that from other things, from fire safety. We actually realise as well, it's there in our ventilation and air quality as well. We learned a few things about risk factors. We learned that buildings aren't a panacea. They don't solve everything, but they enable stuff. They create how many people are in spaces together. They determine how we interact. They give the environmental conditions in that spaces. So they enable, they facilitate, and if those environments are poor, they create risk. But they don't deal with all of the risks. It's really important that we don't forget that there are other things that need to go in there too. I was very privileged to be involved in quite a significant piece of work, again, together with a few other people who are here, particularly noticing Harold's in the room, around infection-resilient buildings. This was commissioned by Patrick Vallance. The starting point was really critical. What do we do to mitigate a pandemic? Then it was actually, what do we do over the longer term? So we brought together experts, we brought together stakeholders, we commissioned research, and we brought together 2 reports. The first one was about very much immediate, what do we do? The second one was that strategic aim. And it was led by Royal Academy of Engineering, and Sibsy's logo is hiding under that picture there that I put in the wrong place. And it's quite interesting when we started doing this, because you see things that you didn't expect when you ask stakeholders. It's not just worry about disease. There's a whole raft of things that happen if you get your environments wrong. Things around the socio-economic impacts of those poor environments, loss of revenue, customer confidence, productivity, all of those feature in there. And they were the knock-on impacts that stakeholders were seeing. And then we also find all of these different priorities come out, that it is undeniably a challenge, and especially if you're retrofitting a building, how do you balance all of these different factors? And we probably have to accept nothing will actually be perfect, but we can do better on some of these. So that work produced a number of recommendations. It produced some immediate recommendations, which have kind of been and gone around COVID, but produced these which are standing for the future. And I think, if we look at these and think about these in the context of not just ventilation and air quality, but any building health and safety issue, they stand. Thinking about what do we do at design stage, at construction handover stage, in use and retrofit stage. And it all comes around the same thing. We need the right standards, but we don't just need those standards and regulations, we need them to link together. We can't just look at one thing in isolation. We need to actually commission and enforce, measure and enforce in use, not just at handover. There's a lot of technology out there, but very little of it has any standards associated. We need to think about how we make sure we've got the right things in place so that when people buy something, it gives them what they bought, what they think they're buying. And then there's a whole raft of things around communication and leadership. And I really hope that we do see that strategic leadership. I mean, a real challenge with air quality, both outdoor air quality and indoor air quality, as there's no one government department that owns it. It belongs right across everywhere. So it's very easy to keep passing the buck. Okay, so what does ventilation do? Let's have a little bit of technical. We create exposures. This is a picture showing exposures from people, emissions from people, and where we might have ventilation through HVAC systems, through infiltration, through natural ventilation. We've also got things like deposition, etc. going on in there. You could apply the same picture to emissions from cooking, from emissions from cleaning products, from building materials. They'll all be subtly different, but you could apply that same idea. Another very basic principle, we have a room, we assume the air in that room is well mixed. We can create some incredibly simple models, double the ventilation rate, halve the exposure. Make a bigger room, you reduce the concentration because you've got more space for it. Life's not quite that simple, but it gives us those basic parameters to start to play with. But the real world is more complicated. We have to recognize that complexity. Very few spaces actually have well-mixed ventilation, some deliberately, some it's just not been well designed. We know things are variable, and especially naturally ventilated buildings. There are so many buildings that rely on natural ventilation, yet there'll be times of the year when either because people shut the windows or because the weather conditions are wrong, they will not ventilate correctly, or they will ventilate from one space into another space rather than ventilating that same space. We know that people mess things up by their being there, just creating heat. We know that actually we have all sorts of other movements and heat sources that happen in buildings, and people change the settings when you're not looking. And we struggle to measure. We don't know very much about ventilation in most buildings. As many of you know, I was involved with the SAGE committee through the pandemic. One of the key questions that kept coming to us was, how many of our buildings are badly ventilated? And the answer every time was, I don't know, but a lot. And because we don't have data sets that tell us this, we don't have commission reports for the vast majority of buildings. We look at some of these. This is thanks to Henry, who's given me, he didn't give me the slides, I just shamelessly stole them off him. But this is measurement in school classrooms. So this is 4 schools measured over from March through to December 2021 through quite a big chunk of the pandemic. This was during a period when the schools were asked to keep their windows open. The big dots are the average carbon dioxide concentration for each month for that school. The little dots are the variations in the individual classrooms. What you see is generally things are better in the summer than the winter, as you might expect. But you see there's quite a big spread in there. Some of those classrooms are well ventilated, others probably not. These are all naturally ventilated. These are people who are trying to keep their classrooms well ventilated. I really dread to think what these look like this year. But it's really interesting as well. You start to spot the behaviours, because the top two are the same school, the bottom two, the same school. These classrooms have the same architecture. They're normally next door to each other. They've got the same number of kids in them. They've got the same weather conditions, yet their ventilation rates are different, which is telling you there's a huge behavioural factor in terms of people opening the windows. And, that's a real question for us, is how much we can rely on behaviours and just say, we've designed it, it's fine, ventilation will work. Doesn't quite. So what is a good environment? I think these are really big questions. I'm not actually even going to answer them, but what do we need? What are the metrics? What are the right measures that we should have to say it's a good environment? And what's the right measure for health? We can put a measure for energy. How do we measure it for health? Really challenging. How does that link to what people do in that building? What do we know about what exists? And how do we get the data to do it? When we're thinking about creating buildings that are resilient, there's an immediate sort of, let's buy a technology because it's really, we like simple measures, but that's not the answer necessarily. We need to think about this in terms of what we can do, same way we do with any building design. What can you do as part of your passive strategy first? If you get your thermal environment right, it helps you ventilate it better. Thermal environment's poor, you're going to struggle with the ventilation. You get your daylight right. Again, that's going to help you. But we like to have low ceilings, we like small windows, we want to save energy. We need to think about the whole passive thing. And I've stuck water systems in there as well, because I often talk about infection resilience. Water systems are all part of that. So that's perhaps another thing, but it's linked in about buildings and health. And then we have the technologies, okay, mechanical ventilation systems, but things like filtration and newer technologies, UV air cleaning type technology. Some of these approaches we've known for a long time. We know that filters work. Other things are coming along. This is actually a graph from work we've been doing recently on far UV, which is a particular wavelength of UV light, 222 nanometers. It works. But just because it works in our test environment doesn't necessarily mean it's a panacea and we can throw it into every building straight away. We really need to understand how these technologies integrate with everything else in the building, how people accept them, and to try and get some evidence for how they work in the real world. And there's a lot of technologies out there. Always look for, is there some proper independent scientific evidence for it? Or is it just a sales pitch? We have evidence there for ventilation. It's really hard to actually say better ventilation leads to better health. But people have done studies. The vast majority of these studies are before the pandemic. People have over the years said, okay, we can show that in schools with better ventilation, the kids have better test scores. Workplaces and schools and in lab type settings, you can show there's a correlation between cognitive function and the ventilation, the air quality in that space. We know, we can show from evidence that better ventilated buildings have lower asthma rates, have lower respiratory symptoms. We know that they have ventilation, air cleaning, UV studies all show lower sickness absence, lower incidence of sick building syndrome in there, productivity, performance. There's a lovely study from Denmark that shows that if you open the window or have better ventilation when you sleep better, you perform better the next day. It's ventilation, good air quality is part of the building blocks of life. It's part of the things that make us form and function well. And just to these snapshots in here. So yeah, poor indoor air quality, this is another Danish study, could reduce your productivity by up to 9%. Think about that in terms of a business. Nearly half a day a week. That in terms of salary costs alone, is going to dwarf your energy costs. 2019 ONS statistics, 5.3 million workdays in the UK lost to respiratory infections. I mean, this isn't just about, health and well-being. There's a massive economic case for this. And 20 years ago, people looked at it in the US and said, you could get annual gains of 40 billion. And that study just gets ignored. We know that this works. But we're still being asked for more evidence. And this is a study that's ongoing at the moment. I really hope we'll tell you the answer in the next few weeks. This is a study in schools in Bradford to say, do putting air cleaners in those schools reduce COVID rates in those schools? You have to do, yeah. I wish we didn't have to go and get this evidence, but we do. And actually, I hope that when we get the evidence, it will really help move things forward. Interestingly, lots of people say put air cleaners in everywhere, but we also find there's a bunch of practicalities. Lots of little things like there aren't enough plug sockets. And then when you come to put some more plug sockets in, you discover the school hasn't been rewired since the 1970s. So you have to rewire the classrooms before you can do anything. Or there are so few plug sockets that people keep unplugging them to plug something else in instead. Robustness. Nearly all of our air cleaners have got Lego inside them now. Kids post things in them. So you have to think about these practical factors, but it's not insurmountable. It's about thinking through the processes, making sure you've got the right systems in place, enabling. Okay, so is it all worth it? Well, yes, there's evidence, but we know there's a cost, and sadly, everything comes down to money. So yeah, ventilation costs money, air cleaning costs money. There's capital costs, design costs, maintenance costs, etc. in there. There's some time and resource costs. But there's also possibly some benefits in there. If you put in better heat recovery or you put in air cleaning, that probably is lower energy and lower running costs than what you have now. This is the hard bit though, because how do you cost the health impact? The health and economic impact is massive, but it's really hard to put those numbers through. But we know it creates disruptions, it creates problems with productivity, it creates long-term sick, which impacts on treatment costs, impacts on the backlog in the NHS. It all ties in together. And it actually also affects the building. So the building health matters in here too, albeit try and focus a bit more on people if we can. It is cost effective. This is from the Royal Academy of Engineering report. It's basically looked at putting together a model for saying, is this cost effective in terms of infectious diseases? And yes, in community buildings, schools, hospitals, public buildings, etc., there is a cost-benefit ratio greater than 1.5. It's a benefit. And that was a fairly conservative estimate. Commercial buildings is too. Much harder to prove this for transmission of disease in the home. I suspect if you looked at other health effects, though, you could show it in there. So what do? We've got to enable change. We've got to do things differently. We would love some magic bullets. We'd love something really simple. Actually, the real world is messy and complicated. We've got to recognize that. But we have to think about people's embedded beliefs. Oh, if I open the window, all it'll do is waste energy. No, it's beneficial for your health as well. You've got to think about them in tandem. We've got to think about, we've got lots of science. We're not very good at getting that science into practice. We've got to think about how we do that better. How we think about those real world problems, the real world challenges and trade-offs to take things through into practice and make sure they work properly, which includes the behavioural aspects of it, making sure people know what to do with things. We've got to get that economic case out there much more robustly. And there's a whole piece around education and communications that still needs to happen. So to finish, this is where we want you to help us. So this is for everybody in the room. On the 8th of November, it is the very, very first World Ventilation Day. Yes, please photograph this one. Please remember the hashtag with the 8s in it. It's not an accident, it's the 8th of November. This is about us championing things. This is about us saying ventilation matters. It matters for people, it matters for health, it matters for the economy. It's about celebrating, telling people, how do you ventilate well? What is good about ventilation? But also champion the people across this room who work in it. All of those unsung heroes who help make buildings better, champion it. So please join in with us. Please don't just use it as a sales pitch. Please just give us really positive messages about ventilation. We're on Twitter, we're on Instagram, we're on LinkedIn, we're on the web. You can nab the logo, use it, join in. If you've got any events coming up, if you've got any launches coming up, tweak them to go on that day, please do. I want to just say a big thank you because an awful lot of people have been involved with an awful lot of the work I've done. So just acknowledge thank you to all of those. And I'll go back to that one to leave that one there. Thank you.
Okay, we've got time for a couple of questions. Henry Burridge, who you mentioned earlier, is here, so we'll do that. While we're getting a microphone to him, just one question. How long do you think it would be before every building, we know what the air quality is within that building, and we treat it like water? We consider that the air we breathe is something we need to know the quality of. Every building? Probably never. But I think you could get to 80% of buildings in 10 or 15 years, realistically, because you can use things like CO2 monitors. It doesn't tell you everything, but it'll give you some simple proxies that will at least give you those initial starting points. Whether that data gets reported to anybody is another question. Thank you. So, Henry, no microphone? Oh, here it comes. Nothing like being prepared, is there?
Well, just to prove, fantastic talk, Kath. Just to prove this isn't a setup, I'm going to ask you quite a cruel question. And this is in part, I know you have a new role with the HSE. And my question is, in your personal opinion, do you think there is a role for government enforcement of good indoor air quality or not?
This is because I asked you a hard question earlier, isn't it? Yeah. Yes, I think there is. I think there's a long haul on that. I mean, there is already a role, both through HSE and through local environmental health officers, in enforcing ventilation in certain settings. But to be honest, at the moment, it has to be truly terrible for them to do anything about it. I think longer term, there could be much more of a regulatory role in there in terms of making sure we've got a level of compliance. I think we need to move to a place of facilitating people to do it, giving them time before you put that regulation in. But I absolutely think there should be some means of enforcement and people to demonstrate, what's the ventilation like in this building? What do you know? If we've organized, VISA have organized an event here. Wouldn't you have a right to be able to say, am I organizing my event in a building that is healthy, safe? We hope it is. It doesn't feel too bad. Been in worse.
Well, Adrian, sorry, one further question.
Is this an all or nothing problem? Because are we going to solve the problems in buildings like we're in today? And what are we going to do about the house that you go back to later on? Because is that as important an environment as the public spaces we occupy?
Sorry, just say that again.
Is it an all or nothing problem? Have we got to solve the housing issue as well as the public space issue? Are the two have got to go hand in hand?
Ideally, we have to solve it all, but I think we shouldn't say, well, we're not going to do something here because we can't do it there. I think it's one of these things that every step we take, every environment we improve helps. And that's not necessarily saying that, spaces which are already quite good need to go to an extreme level of ventilation by any means. I would love to see just those spaces comply with the standards they're supposed to. But yeah, we should be tackling everywhere. Reality means we're not going to do everything, but we shouldn't stop doing some of the things because we can't do everywhere.
Right. Well, thank you very much indeed, Kath. That was fantastic. And thank you for your support over the years.